Hello everyone, welcome back to Machine Learning with Tensorflow. In the last tutorial, we have seen how to build a neural network in Tensorflow and how to train it. In that example, we have got some new terms, and in this tutorial we will learn about those terms. The first one is the bias. What is the bias? The bias works as the reference for the layers. It prevents the training process from digressing randomly, and you can add bias in each layer of the network, or you can add to some of them. Next comes the training process. You can train it online, batch, or in mini batch fashion. For example, if you have say 21 training samples, you can pass one sample at a time, and you can change the weights based on each sample separately. This is known as online training. As an alternative, you can also pass 21 samples and find the error for each one of them, make the sum of the error, and backpropagate the sum of the error and update the weights only once for the whole sample. This is known as batch training. There is something in between online and batch training, which is known as mini batch training. In mini batch training, you do not update for each sample, you do not update for the whole sample. Rather, you take a mini batch, for example, say 5 samples. After each 5 sample, you will update the weights. In our example, we have used gradient descent optimizers. However, there are some other advanced level optimizers like stochastic gradient descent, AdaGrad, AdaDelta, Adam. Adam has become the most popular among the community in recent time. One important aspect of the optimizer is learning rate. The learning rate defines how much your weight should learn from each epoch. You can make it large so that your weight gets updated at a higher rate, but usually the higher rate does not give you the optimal performance. In general, the slower the learning rate, the better the performance. For example, if you see in this plot, if you look at the rate curve, it starts learning very fast, but it ends up in a non-optimal position. But if you think about the green curve, it takes some time to start improving, but it gives you a better performance. Cost function. In TensorFlow, you can define your own cost function. It can be as simple as mean absolute error or mean squared error, as well as some complex cost functions like cross entropy. The cost function should be defined based on your problem. For classification problems, categorical cross entropy is preferred. But for regression problem, you can use mean squared error or log loss. You can get a complete list of built-in cost functions in the documentation of TensorFlow and Keras. I always suggest that you look at the documentation online. You will be able to learn a lot about deep neural network from these documentations. What are the layers you can use? In our example, we have used only one layer, that is the fully connected layer. And fully connected layer is used in all neural networks. But there are some other layers which are specialized for different area of applications. Like for time series and natural language processing, the most commonly used layers are recurrent neural net, LSTM, GRU, attention, dropout, etc. For computer vision, the most popular is convolution layer, maxpool, attention, dropout, and some other layers. In the next lecture, we will start with Keras. We will have our first program with Keras. So that's it for today. Thanks for watching.